Parallelism. Parallelism. And obviously, the word parallel is in that word, so what we're going to do is first define parallel and draw a picture of two parallel lines the way you see. I'll give you about a minute to draw this. And define parallel. Two lines that never intersect. I'm going to write that down. Two lines that never intersect. Because these lines go on forever and ever, we call them parallel. And here's a parallel symbol. This double bar here means parallel. And notice this top line, we named it line AB by the 2 points and the little line symbol. So this means line AB is parallel to line CD. Look at CD. This little line symbol is just a way that mathematicians name lines. Right, Rodriguez? You got to have the floor, phones away, earphones on. Awesome. Okay. And these double arrows here, see those double arrows? That's communicating that the lines are parallel. Whenever you see that picture on a geometry book or a textbook or some test, a benchmark exams, a SBAC exam that's coming up, whenever you see those arrows, that's communicating to you that the lines are parallel. Right? Again, these double bars are the symbol for parallel. Now, let's compare that now with perpendicular. We'll write the word perpendicular in your notes. Notice these two lines do intersect, but they intersect in a very special way. They form right angles. Go ahead and copy that down, the definition and that picture. The perpendicular symbol is like an upside down T. Look at it. And all perpendicular means is two lines forming 90-degree angles. They intersect, crisscross, 4 right angles, as opposed to parallel. Okay? Parallel never intersect, perpendicular do intersect to form right angles. Again, take special note of the symbolism. Perpendicular versus parallel, right here. Okay? Question so far. Two straightforward definitions. That's going to come into play now with what I'm going to present to you, which might be a little scary. Now, veteran students, Math 2 veteran students, we're now embarking upon content you haven't seen before now. Where I said a little overlap from last quarter, the first 2 weeks. Now, we're trailblazing new territory. So stay with me. Here we go. We know what parallel lines are now. Now check this situation out. What if you had this situation? Go ahead and draw two parallel lines here. Look at the two parallel lines are indicated with the 2 red arrows. But not only draw 2 parallel lines, go ahead and draw a third line cutting through the 2 parallel lines, if you would, on your notes. Take a minute to draw this situation. 2 parallel lines cut by this third line, and look at how many angles are formed. All kinds of fireworks go off. Okay? I got a total of 8 angles formed when a line cuts through the 2 parallel lines. Go ahead and draw that for me. This third line right here that cuts through both, let's call it transversal. This third line right here. Go ahead and write transversal and put an arrow out that third line that cuts through both. And go ahead and quickly define a transversal. It's a line that cuts across one or more other lines. Transversal. Think of the prefix trans, transatlantic airline that goes across something. Transcontinental railroad, the railroad that went from one end of the United States to the other. Transgender, you're going across gender lines. Transvestite, you're going across protocols of stress, I suppose. But the word trans means going across something. So this line's going across the two parallel lines, hence the word transversal. Works. All kinds of special things happen. Here we go. The total of 8 angles here, there's special names for those types of angles. And that's what we're going to get into right now. That's our notes. Check it out. So you have 8 angles formed when 2 lines are cut by transversal. The first type of angle that I want you to write down is corresponding angles. We're going to list the corresponding angles in reference to our picture here. So we're going to write the word corresponding angles. Put a colon. We're going to list them. In other words, which angles here are corresponding angles? All right. So corresponding are going to be the angles that occupy the same position in reference to the parallel lines, and they're going to be on the same side of the transversal. Here's your transversal. Look at the pair of corresponding angles. Check this out. Angle 7 and angle 6. Actually, angle 7 and angle 3, what am I saying? Okay. Angle 7 and angle 3 are corresponding. So we're going to write angle 7 and angle 3. They're corresponding because notice they're both above the parallel, each parallel line, and they're both to the right of the transversal. They occupy the same position, so to speak. That's why they call them corresponding. They have corresponding positions. Again, 3 is above this parallel line and to the right of the transversal. 7 is above that parallel line and to the right of this transversal. So it's like the same position. Look at another pair. Check this out. Angle 6 and angle 2 are corresponding. They even look the same. They look the same. 6 is below the parallel line. 2 is below this parallel line. 6 is to the right of the transversal. Look at my right hand. Here's your transversal. 6 is to the right. 2 is to the right of the transversal. So angle 6 and angle 2. So I'll put a comma here. Angle 6 and angle 2 are corresponding. They even look the same. Notice. So far, so good. Can anybody give me another pair of corresponding, the ones that look the same and occupy the same position, so to speak? Anybody yell one out? 8 and 4. I'll color code it with blue here. Notice 8 is above that parallel line, and so is 4. It's above that parallel line, and both 8 and 4 are to the left of this transversal. Very good. So we're going to write angle 8 and angle 4. Moving right along. Last but not least, angle 5 and angle 1 are also corresponding. I'm going to put that also. Angle 5 and angle 1. Okay, so far so good. 2 lines cut by transversal. Corresponding angles exist, but not only do they exist, they also look the same. In other words, if I were to take the degrees of angle 3, it's the same degrees as angle 7. If I were to take the degrees of angle 6 with a protractor, it'd be the same degrees as angle 2. So off to the side of corresponding, the special feature about these angles are they're congruent. Okay, put a little congruent symbol. They're the same measure. Remember, that's what congruence means. Equal sign with a little squiggly above it. So these angles are the same measure. It's just a factoid of reality. If you have 2 parallel lines cut by transversal, corresponding angles are always congruent. All right. Next kind of angle. Same side interior angles. So write that down. Same side interior angles. Oh, I don't know. Yeah, this guy's right. Same side interior. All right. Now, the word same side means that's referring to the transversal. What are some angles to the right of the transversal? Can you guys name me some angles to the right of the transversal? Just name some randomly. 3 is to the right. What else is besides 3? 6, 2, 7. These 4 angles are to the right of the transversal. 8, 5, 4, and 1 are to the left of the transversal. So when I'm saying same side, I'm talking about angles on the same side of the transversal. But same side interior. What do I mean by interior? What I mean is the space in between, Fenderson, the space in between the 2 parallel lines. Look at right here. This is the interior. So just by the name, same side interior, you can kind of decipher what angles we're dealing with. Someone give me 2 angles, same side interior. Same side of the transversal and in the interior. This is the interior, all this is exterior. 3 and 6. Look at, they're both on the right side of the transversal, so they're the same side, and they're in the interior. And then 5 and 4 on the left side, they're on the same side, and then they're interior. So this is the interior. Everything in between the 2 parallel lines is interior. So let's do it. Angle 5 and 4. And 6 and 3. Okay. Same side interior angles. All right. Now, what's special about same side interior angles? Are they congruent or are they supplementary? Well, these are not congruent. These are supplementary. So I'm going to put SUPP next to same side interior. What does supplementary mean again from last week? Does anybody remember? Before you break my heart. What does supplementary mean? Angles at what? Angles at what? Add up to be what? That's congruent. That's when they're equal to each other. Supplementary means add up to be 180. So what I'm saying is, look, if you have same side interior, 6 and 3, they add up to be 180 all the time. And 5 and 4 add up to be 180. If you have 2 lines cut by a transversal, a lot of special things happen. Let's keep going. Third angle. Just 2 more. Alternate interior angles. So write that down. Alternate interior angles. Alternate interior. All right. Now the word alternate has to do It's the opposite of same side. Alternate means on different sides of the transversal. So, and they're interior. So alternate interior would be this space in the interior and angles on different sides of the transversal, hence the name alternate. So alternate interior would be 6 and 4 and 5 and 3. 6 and 4 are alternate interior, and 5 and 3 are alternate interior. Notice they're on different sides of the transversal. So we're going to write that down. Angle 6 and angle 3. And angle, actually 6 and 4, my bad. Angle 6 and 4 and angle 5 and 3. Now alternate interior angles are congruent. So next to this one, I'm going to put a congruent symbol. So we've got corresponding angles are congruent, same side interior angles are supplementary, alternate interior angles are congruent, and last one, last but not least, is alternate exterior angles. Last one. Alternate exterior. So alternate, different side of the transversal, exterior. That means they're on the outside. So I'm no longer talking about angles in the interior. I'm talking about angles out here, outside the parallel lines. Give me one, Franco. Okay, but 1 and 2, notice, they are all alternate. They are exterior, but these are a linear pair, huh? You see? So it'd be, well, 1 and 8 are on the same side of transversal. Keep thinking another one. 1 and 7. Alternate exterior. 2 and 8 is alternate exterior. Good. Alternate means different side of the transversal. Exterior, outside. So let's go to write 1 and 7 and 2 and 8. Angle 1 and angle 7. Angle 2 and angle 8. And alternate exterior angles, what's the special feature about them? Well, they're congruent. I'm going to put an equal sign also with a squiggly. So all these 4 angles I threw at you, only one of them is supplementary to same side interior. The rest are congruent. They're equal to each other. Cool. I'm going to throw 2 examples at you of how to use these relationships, and we're done for the day. Here we go. Okay, here we go. Example 1. I'm going to copy this down. Let's use these relationships now. Hello. What is it about this picture that tells me that I have a parallel line with anybody? There's something about this picture that communicates, hey, you're dealing with parallel lines. What is it about this picture? Go ahead. Arrows, right there. That gives it away. These 2 lines, if they were going to infinity that way and infinity that way, they would never touch. That's what parallel means. It's like the 60 freeway and the 10 freeway. They're parallel. At least to get to downtown, that's when they merge. And we get to Beaumont going eastward, maybe they merge. But other than that, the 60 and 10 freeways are parallel. Someone besides Franco, what is this third line called? That cuts through both. Henderson, hit it. Transversal. Good. We got 2 parallel lines, thank you, cut by transversal. A bunch of fireworks go out. You got all kinds of special angles going on, and you got to figure out which ones. In other words, you have these 4 going on. Just go down. So our task is to solve for x. In order to solve for x, though, we got to figure out what relationship is there between these 2 angles. So this angle of x and this angle of 4x minus 5. The question is, what relationship is there between them? So you got your transversal. They're both on the right side. That'll be same side. Which one? Same side interior. Look at, they're both in the inside of the parallel lines. Look at their, like inside a house, the interior of a house. Look at their inside, both. And they're both on the right side of the transversal. So we're dealing with same side interior. And if we look at our notes, same side interior angles are what? They're supplementary. What does supplementary mean again? Anybody? Equal 180. Let's do it. There's our equation. Watch this. So I'm going to go ahead and write on the notes, I'm going to write same side interior, SSI. Same side interior angles. And I know that same side interior angles are supplementary, so look at the equation, the logical equation. This angle, x, plus that angle, 4x minus 5, equals 180 degrees. We're no stranger to these long equations. We've been doing it all last week. It's getting older. You do this in your sleep, I trust. Let's get x alone now. Let's see. We clean up the left side of the equation, I believe, right? X and 4x makes 5x. Just simplifying there. I got the minus 5. I got the equal 180. All right, let's balance the equation. Let's get x alone. So I will do what to both sides? Add 5 to both sides. Add 5 to the right. By the way, look at my rebalance I brought. Remember, an equation is like a balance. Whatever I do to one side, I got to do the other. Look at, if I add 5 to the right, look at 1, 2, 3, 4, 5. I only added 5 to the right. I got to add 5 to the left now. Or else it's not an equation anymore. It's illogical. It's not equal. So it's add 5 to the left. Or to your right. My left to your right. Not equal. Watch this. 5x is 185. Divide by 5, maybe not. Let's divide by 5 now. And I think that's 30 something, right? Awesome. Done. Mission accomplished. All because we knew our parallelism angles. Same side interior. Added to be 180. Okay. One more example. Questions on this first example. Am I throwing a lot at you? Just out of curiosity, what's your opinion? Am I throwing a lot at you? Thank you. Last one, example 2. Let's go. So again, I got 2 parallel lines cut by transversal. Copy that one down. So I got 2 parallel lines cut by this third transversal. I need to know what this angle and this angle is. I got to establish a relationship. They're on different sides of the transversal. So I already know it's not same side. It's alternate something. Exterior. Interior is where my palm is at. This would be the interior in between the parallel lines. So we're dealing with alternate exterior. So in alternate exterior angles, we wrote down that alternate exterior, notice, they're congruent. They're the same measure. They're the same degrees. So let's do it. There's our equation. So I'm going to abbreviate alternate exterior angles. I'm dealing with alternate exterior angles. They're congruent. So 100 degrees equals 5x minus 5 degrees. Right? The rest is algebra again. We had a lot of algebra practice in this class, if you notice, the past couple of weeks here. Let's get x alone. I'll add 5 to the right, 5 to the left. 5x equals 105. Divide by 5. X is 21. Beautiful.